Yeah, he was very nice. Yep, he was very nice. So sad.
So.
Yeah. So that's part of what each one was a small house. Wish it was more.
It's ordered with us like that.
No, that's what I'm thinking.
Yeah, I've been down that road too.
It's good to see you.
12,000 steps. With a book of funny clothes.
I actually did.
Trailer. Okay, so I get about 6,000-7,000 steps just from that bike.
Cool. After 2 years, never been that low level. Okay, a lot more. Very still love these. I have to walk. He might do well.
We'll get started in another 5 minutes, so make sure you get your drinks over there.
He'll probably work all right now because more than she's not.
Yeah.
She's like
Yeah,
the liver issues happen there right after. He's doing a lot better. You can never drink again.
No, it's not that. She's fighting it back into the hospital.
Sunday. Some type of the one that we saw. They have people coming out. He looked at a lot better. Yeah, well, they said she's working.
Who's this? You can't work from home.
First they have 6 months. Then after that, it's once every department. And apparently, our department is also once. No one gets work. And so then there was a big so once a week, that's it.
So it'll change probably.
She's pretty good. Today, he's like, yeah. Yeah. So,
Somebody had a code.
Okay, so I did all of my, I really worked with templates, so like layout, tab layout, and then you call it. And then he was like, this looks like a mess. And then, oh man, I was like so worried. He was like, well, let me look at it and we'll talk about it. I'll go home and he's like, oh, come on. He said, you know, this for 12 years. So,
I thought your boss was involved.
my boss is a little bit, it's like, she's not that technical. So
Gotcha.
kind of like under his.
I understand.
Yeah, it is. I don't know. I was thinking, looked at it, you know, like it's 2%.
Yeah.
Alright, we're gonna actually start now.
These are just. Yeah, it's just.
If you need access to the internet, this is how the and the key.
How's that here?
Yeah, so go ahead and start it. Thanks, big thanks to our sponsors tonight, Smart Logic for the pizza. They've been with us for a good long time, and to our new sponsor, OAuth2, for hosting us in this really nice space. Really appreciate both of them coming through. They've been a big help. We couldn't do this without them. Some upcoming events just around the area. The DC rug and DC, they're going to be talking about. I didn't know if it's called DC rug anymore. It used to be DC rug. It's DC Ruby user group. They're going to be talking about Salesforce, Rails, and some little bit of Ruby Lambdas down there. So if you're interested in that kind of stuff, it's just hop and skip down 95. February 24th, there's going to be a open source hack night here. It's a really, if you've never been to one of those, it's a great opportunity to just go out and experience some coding with some other people that are working on stuff. You either go to this with some ideas of some open source code you're going to work on, or you go to help other people. At the beginning of the night, we'll ask what people are working on. If something sounds interesting to you, you sit down and work with that person for an hour or two. It's really, it's a great experience. I've never done something like that. It's great. If you've got some open source code that you're working on, you need some help with, it's a great opportunity to get some help. So, highly recommend doing it. It's 2 weeks from tonight, same place. And then next month, March 10th, we'll have React on Rails and serializing value objects in Rails. Right. So, are there any other upcoming events that people want to mention real quick before we move on?
There's a code.
part of the reason we came tonight is so we could just say hi to everybody, here's a little bit more, and we want to talk about sustainable development and hackathon. Kyle had said he was gonna reach out to you, but I don't know if that happened or not, it kind of seems like it didn't, so I feel a little awkward. But, so, Jen with Beta More, I just want to say hi to everybody. Apologize for kind of crashing the party without the approval. Kyle said he could talk to you guys, and I don't know what happened there. But, yeah, it's all good. So we're doing a hackathon with Stanley Black & Decker. They're actually working to take their tools and make them digital and get technology embedded in the tools. And what we wanted to do is they present that to you guys and also ask that, if we can reach out to you, maybe it's by you instead, to share that information. We haven't set a date or anything like that, but it's literally just a shout out to let you know that that's coming in the March, April timeframe. Thank you. Thanks for letting me crash. See you guys. Nice to see some of you.
Girls on there?
Yeah, the women's workshop.
Yeah, so we're actually sold out now, I think. But we've got the Rails workshop for women. What we are looking for is more female coaches. So if you're a lady, you want to coach a Rails workshop, love to have you.
How much time is there?
Hmm?
How much time is there?
Time is there for what?
Until the end.
2 weeks, 3 weeks?
Start with myself.
It's coming up.
Cool, any other announcements? That was it?
Yeah, just, it wasn't, that was all. Excuse me.
Alrighty, so yeah, this is about the time we ask, is anybody looking to hire? Any companies here looking to hire?
So, yeah. So this might be the wrong crowd, but we are looking for a senior Android developer. So if you were someone who knows senior Android developer, so at Order Up.
Everseed is looking for a senior Ruby on Rails developer, so see me if you're looking for a new job. Stack, always looking for cool people.
Anybody else? Anybody looking for a Rails gig or mobile gig? So we've got people over there. Alright. Go around the room real quick, introduce ourselves, and I don't know, something interesting that you're working on that you're excited about. So we'll start over here, Jim Led.
No pressure.
Wait, I mean, if you don't have anything you're excited about, just your name and where you work at.
Ed, work here at Order Up, doing engineering stuff. I've got a fun side project right now taking all the things that I want to be better at and putting it into one app. So I'm doing a Go web app with React on the front end.
I'm Jonathan, I do engineering things at Order Up. Last time I think I said some other web technology, but the conference is convincing that React is the whole thing. That's gonna be like 2015 React, so.
I look at the back.
I'm Ryan, I'm the CTO at Everseed, and this year I'm really excited about growing my team.
I'm Scott. I do a lot of Ember and some React. So Eric, it's Smart Logic. I've been playing around with Docker deployments recently. I get that going.
Brian at Smart Logic. I'm upgrading a whole Rails app to Rails 4. Everything's broken, so I'm really super excited about that.
My name is Oren. I work for Order Up. Technology-wise, I'm interested in R. One of my coworkers is using R, statistical programming language. So it's fun to watch.
I'm Lisa. I am a Rails developer at Space Science. Space Science.
I'm Mike, I work for ProQuest, and this week I'm having fun with JRuby and concurrency.
I'm Mike Sabelski, very passionate about design of Ruby apps.
Doug Price, I work at Craftcraft, and I'm excited to be coaching the Rails women in 2 weeks. So.
I'm Beverly. I work at Develop DC. Currently, we're changing one of our third-party apps.
To use React, or CSS and basic.
I'm Allison, a student at General Assembly in DC, doing the full stack immersive program. This past weekend I did the Art Bites hackathon at Walters Art Museum. I made a Pandora kind of app that's just artworks based on what you like and dislike. So looking to kind of finish that up and get it for my portfolio.
Hi, I'm Sinclair, and I'm having fun learning Elixir still.
It's Josh. We're working on great stuff.
I'm Hank. I'm a Ruby developer at Stack, and currently turning my entire house into a Linux VM. So,
I'm Griffin. I work at Stack, and I'm also a student at UMBC, and writing a compiler for school, so I'm having a lot of fun with that.
I'm Larry, I'm a developer here at OAuth, and I am looking to start writing React this year. I'm Dave at React.com, and just learn Jenkins and shit.
I'm Shiromani. I'm a .NET developer but Hero Price. On my side, I'm getting my hands dirty with the Android Asterix on Raspberry Pi.
I'm Andrew. I do medical imaging in radiology at Johns Hopkins. So it's all old school scientific computing. I'm excited to be in a language from this century.
Yeah, Robert, I'm perennially about to create my first Rails app.
You say that every time.
I know, it's always when I get distracted.
Brian, I work with Stack, and excited to kind of retool our front end a little bit. This upcoming year.
I'm Nick, and I work at Maelstrom.
Mike, and I do PHP and Ruby on Rails.
Dave, I do a little freelance work in Rails, CSS, JavaScript. Looking for a full-time job.
Well, did we get everybody? All right, I'm Chris. I'm excited about Polymer, mostly because I am going to get that book done. Keep saying that, but this next month I'm going to be done with it. Really, I am. Move on to something else.
Can I ask a question? Is there a guest Wi-Fi?
I'm sorry?
Is there a guest Wi-Fi here?
The password's back there. Wi-Fi password. Top left.
All right, so the agenda for tonight, first up is going to be Mike. He's going to talk about distributed application architecture. And then Eric is going to talk to us about OAuth2. Then afterwards, we'll probably head over to one of the bars. Just a group of us will move down over around 15 minutes after the presentations are done, and just keep the discussion going if you're interested in that. One other thing, we're going out live over the Hangouts. Sorry for the Hangout people who couldn't see us while we went around the room there. But we are going out live over the internet, so watch your language. Jonathan. With that, I'll turn it over to.
All right, hope I'm in range. All right. Hello, everybody. My name is Mike Spelsky. I've been giving a version of this talk at Cuba on Rails for a few years, and I felt I never quite got it. So now I think I got it. So I'm very passionate about the way big, complicated enterprise software apps should be built using all the really cool open source Ruby and Rails stuff that I've learned, but marrying it to all the things that I've had to learn the hard way. I'm completely self-taught about building enterprise apps. So let's dive in. When I really thought about what's the organizing principle, what I'm so excited about, I'm always preaching in a messianic, fervent way, is really just like taking the single responsibility principle and expanding it to every layer of abstraction in your application. So, just to review, every class module should have one single responsibility, one reason to change. Like entirely encapsulated in that one place. As a result, if you do this, you end up with classes that are not more than one screen long, usually. You don't have a lot of private methods. It's very easy to comprehend. So every little piece of your app, maybe at the end of some long tree of dependencies, there's this beautiful leaf that's really easy to understand. Okay, well, what if we took the single responsibility principle and we said, actually, also every library you use, every engine, every app is itself concerned with one single responsibility instead of trying to do everything. So I bet a bunch of you guys work on something that's got many, many lines of code that does authentication. It has 50 controllers. They're nested. You have namespaces. And you have umpteen million models. Just like everything. And it probably takes you a half hour to run your testing. I say that because the last company that I worked with, we had that problem. It takes a long time to even deploy the code because it's just all the stuff that had to be sent. Our app in the main web app only has, did you guys know this? It only has like 5 controllers. And I'll show you later, like the most interesting one is only 6 lines long. Okay, so I'm going to show some examples. At the method class module level, you're probably already familiar with that. That's where like the actual specific heavy lifting happens. That's where you're sending messages, you're computing things, you're returning a value. We use 35 proprietary gems. So we package up all that specific behavior into modules, gems, or engines, which are also gems, that have like functions. I'll show you an example, but like the thing that renders the view of reports in our app is one engine. We have another engine that just deals with admin authentication. We have another engine that deals with designing reports. And then at the app level, you're taking all those packages of code, those gems, engines, and you're providing high-level coordination, dependency injection, and state, putting things in and out of the database, serializing, deserializing. Oh, right, I have examples. So at the method module level, you're talking about like one real specific thing that is doing in great detail. At the gems and engine level, you're talking about a collection of behaviors that's useful to shift around that many different apps may want to use. And then at the app level, this is where you're talking about web requests, security, getting stuff out of the database or off your queue. All right, so this is currently what Stack's system looks like. It's 9 different apps. Each has a different responsibility. The ones that the users only see is web. Everything else supports web. We have a completely separate Rails app that has all of our admin functions, which if you only remember one thing, that is a big useful tip because it's great to be able to deploy that admin app a million times a day and not worry about affecting it. You make quick bug fixes and it's really nice. And the web apps tests will take less than a minute to run, by the way. None of these take more than maybe 30 seconds actually. I would say 30 seconds. Anyway, most of those, the web app is Rails, the admin app is Rails using the Rails admin engine, and then everything else is like other simple, we don't use all of Rails. We have Sidekick that loads up active record, that's about it. And I'll show you some examples of these. The reason this works is because they all share a common communication bus. Mostly it's Postgres, but we also use Redis because that's what backs Sidekick, which I'll show you an example of. And then I'm sort of also including Pusher in here, which is a WebSocket service, because what will happen is the user will do something in the web that ends up going through an engine and getting put into the Sidekick queue. A report gets generated, some massive computation happens, and then we have to tell the user that it's ready. So the way we do that is by going to Pusher's API and saying, hey, send this a WebSocket notification out. And that's actually how it round trips to your browser. Okay, so in this model, the web app is really just like the simple the screen. It's like if it's MVC, the web app is just the controller, really. It just accepts web requests and tries to do as little work as possible, which means it's relatively bug-free and relatively secure. There's just not that many. The attack surface is very small. And really, the way I think of it is the web app just knows about requests. I got to request in, I got to give the user a response back as fast as possible, and I got to delegate the work to somebody else. So this was the controller I mentioned. The most interesting controller I could find in our web app was the thing that does pusher authorization. So when JavaScript tag runs in the browser, the pusher library calls back to us and says, hey, is this person actually allowed to receive WebSocket notifications from you? And that's where the logic is. So a couple things to point out. You have to be pretty disciplined if you're going to code this way. So I couldn't help it. That's one to mark this up. So for one thing, it's easy to mock in to substitute the pusher authorizer service when you're unit testing this controller. I never write code anymore that returns a result that you test the success on. With that, that's a really ugly pattern. It makes you have to test both legs of that. It ends up being much cleaner. If I was writing that right now, the authorized method would yield an error message to you if the person wasn't authorized. Otherwise, the person. I have some other examples of that later. Okay, the Sidekick apps for us is where the actual hard work is done. They're not under pressure to answer a web request. Some of them can run for hours. We try not to do that, but if that happens, it doesn't mess up the whole rest of the app. Everything's kind of self-contained. But the workers in a Sidekick app are similar to controllers. They're this outer layer of logic where they take something out of Redis and load up the object graph, do a couple checks, and then hand off the behavior to another library. So here, the way our library code kicks in is in the load form. I didn't include the screen that shows what those are, but all the objects that are receiving messages here are stuff that's provided by our gems. So you can work with this code and not know any of the low-level details of how to connect to our database or how to authorize people who's allowed to look at what. That is completely encapsulated away from this. All you have to do is worry about the most high-level behavior here. So I marked this up. The top, I have dozens of workers that work the same way. They get some unit of work. They double check to make sure that the work is in a state that you can actually do something with. We basically try not to have anything happen in our system that's not being tracked by a record and database. So mainly dealing with collection missions that describe some data we got to go get, or we have report jobs which describe data we got to pull out of our warehouse and publish somewhere. Sidekick, by the way, only guarantees at least once delivery, so you end up having to do some extra stuff to make sure, hey, did anybody else already work on this? Am I okay? This is cool. And transactions can be really important for that database. Okay. And then I think the only thing that this one doesn't do, which I would sort of fix later, is typically the last line of the worker is updating the work to say, all right, it finished or it failed. I think in this case, the load coordinator does that. Okay. Some of the other apps we use this is about all the code that there is. It uses the gem called Clockwork, which is a similar interface to cron. You have regularly recurring tasks. After you write a certain number of those cron jobs, you just end up, it's much nicer having this. You get nice exceptions, and logging messages and stuff like that. So I've had a lot of success with this. I really like it. Okay, so this is a talk that Gary Bernhardt gave. I've got focus of mine. I'm using the slide here because another, kind of alongside the single responsibility principle, is this idea of having an imperative shell surrounding a functional core, which I think is really, I realized that's what we've been getting at this whole time. I can't say all of our code is perfectly like this, but personally, this is what I try to do all the time. The shell would be like your Rails controller or the Sidekick worker. It's dealing with the dirty internet, terminating SSL requests, saving stuff to disk, publishing stuff to S3, all that stuff that, there's a lot of things that can go wrong, many failure modes. The stuff in the middle can be written in a very functional way, where most of the gems that we're talking about, they just know about how to make a SQL query. They don't actually know how to run a SQL query or where it should run. They don't really care. They just know how to interact with the double-click ad server. But they don't. There's no results aren't saved anywhere. It's just handing the results back to a callback. And so the code in the middle can be complicated, but it's easy to reason about. It's like the bugs that we have tend to be laser pointer. It's going to be between that boundary, between that functional core, where it's just functions passing each other values and that outer shell. So we have bugs, but I don't know, maybe you guys disagree, but they seem like they're obvious. So, we know right where it is. It's always right in that little ring in the middle. And it might take a while to figure it out, but we don't have too many highs. Okay, so he also, this is a cool diagram. One of the ways to think about what I'm trying to advocate here is that it could be a bunch of different apps, a bunch of shells surrounding functional cores. Turtles all the way down. Okay, so we have, like I already touched on this, some more details about how we package up all that business logic, sort of like components. We have 35 gems and counting hosted on GitHub. We don't have our own gem server. We just pull them right off of GitHub, which has got pluses and minuses, which I can get into later. And it's pretty common for us to like have one of these gems and realize actually it's getting a little too big. We need to split it out into two things. And the main rationale for doing that is we want to share something. So for example, the smallest one is stack text matching. And we basically need a way to let staff members enter regular expressions and run them against arbitrary chunks of text on the fly. They need to be able to test it themselves and experiment, and they have to put the matches in the right order, so the priority and all that stuff. So I knew right away I wanted to make this gem because I wanted to have a really cool little UI that our admin tool could exercise this behavior, but I also wanted to make sure the exact same algorithm is running in the collection system that actually executes the matchers in real time. And then on top of that, we need to make sure this exact same algorithm is running on the developer's machine when they're actually trying to get the extraction code working. So, but this is it. There's no other files in this gem, and it's great. This test runs about 5 seconds. It's very reliable. If there's something that needs to happen with text matching, it's super obvious where to go change. And I haven't been highlighting it, but along the way, there's been examples of that deal on error stuff. Okay, so speed things up a little bit. I want to touch on the main thing that made this all take off for me was to treat the database as your communication bus, as this fortress where the data is always high integrity, it's perfect. There's never a null when you don't expect one. Foreign keys are enforced. All the stuff that when I was starting in Rails was like, David Hammer Hansen saying, oh, a lot of disdain for what the database can do. But I'm telling you, making something that's dealing with like millions of dollars, I really love client data. I love having that kind of protection, decades of research benefiting our app. And everything that you would want to do in an active record macro, I should say like a callback, before save, after destroy, it's better off being done in the database. And because if you do it this way, you could build an app that's highly composable, like I've been showing you, where we have 9 different apps that don't know anything about each other. All they know is how to connect to Postgres or how to connect to Redis. So every piece of work ends up being associated with a row somewhere in Postgres, and every piece of work has a column in there. All those tables have a column called state, where you keep track of, is this a new piece of work? Did it succeed? Did it fail? Are we retrying it? Are we getting ready to try it? Anything that would be significant to the customer as a state. We use transactions to make sure that we don't get tripped up by that delivery, at least once delivery thing I talked about. And then I'm going to show an example of this in a minute, but Postgres has a really cool messaging system inside of it, so you can broadcast events. You can say, hey, this thing just got deleted, this thing just got inserted, does anybody care? So I got this, I was very influenced by this book I read about 6 years ago. It's kind of an old book now. This was written when REST was still kind of a big deal in the Ruby world. This was a guy who worked on stuff like Amazon's trading app, eBay, and then became a Rails developer. So it's a really cool synthesis of really new stuff and really old, battle-tested advice. A lot of stuff comes from it. I remember this guy Dan Chapman. I just want to like shake his hand because it changed my life. All right. So really quick example of stuff you can do with the database. This is something that's like the core circulation system of our app. is this trigger right here. We have probably 20 of these that just watch for events on different tables. So when a user first gives us information about a new connection, there's a bunch of things that we want to have happen. And so the way I keep that logic all separated and isolated is through these messages. So when a new connection is inserted, this function gets called, and all this function does is make a new, like an audit record. Hey, somebody just changed the database. Here's the ID number, here's the table, in case anyone wants the references for later. And then I have another trigger, which is uses the BG notify function, which says, by the way, if anybody wants to know, there's a new audit record that needs to be processed. Anybody cares? Okay, so then one of the apps I showed you was the event handler, which was just a loop. It's just like this is a Ruby class. Or I have a runner that just says start, and it just loops and blocks on this listen method, or wait for notify. So it just sits there until one of those new things comes in, and then the event handler here just says, did anybody add a class to our app that cares about the event? So we may or may not have an event called connection insert handler. If we don't, we ignore it. If we do, all right, start going. So Postgres isn't great for everything. That is the default tool that I reach for inter-app coordination. But since we have Redis anyway with our Sidekick installation, there's actually some really cool stuff that Redis can do. There's a lot of primitives built into it that are tailor-made for this kind of like decentralized work coordination. So the main three things that we use it for are semaphores, rate limits, and queues. So this is from our Rails admin page. This is like one particular connection in our app. We want to make sure that we don't have, you can't hit this connection more than 3 times simultaneously. Because we have had incidences where, the third-party APIs actually want us pulling down 100 gigs of data 2 hours. So these semaphores are they're keys in Redis that expire after a while. So when some code runs that wants to check out one of these connections, it can keep it. If you don't check it back in after a certain amount of time, it will automatically expire. And why that's important is we have extremely disparate kinds of things that our code's doing. We're talking to hundreds of third-party APIs, and so we have a significant number of VM crashes all the time. So of course we have like a block that says, hey, use this work. If there's an exception, check the semaphore back in. But if you crash, you can't do that. So this is something that will be hard to do with a relational database. Redis is perfect for it. Connection limiting, also very similar. This is the Sidekick UI. So Sidekick is our queue. So Redis has a bunch of stuff that makes queuing really easy. You can see like retries and schedules. And the thing I sort of wanted to point out was that when you're building apps like this, failure modes are just as important. In some ways, I'm more interested in how does this thing fail, because I know a 1 in a million occurrence is going to happen every day, because there's a million events. What's going to happen at least once. So it's one of the things I really like about Sidekick is it makes the failure stuff super easy and obvious. Okay. I don't want to say too much about this. You can ask me about it after, but there's one part of our app that I haven't talked about that changes a million times, changes very frequently, and we don't want to have to redeploy the app. So we actually put some code into the database that gets fetched and evaluated. And obviously it's not from the internet, it's from us. But it's a DSL, and the reason this works and doesn't kill us is because it's nested in so many of those imperative shells and functional cores that it's running in this very comfortable sandbox environment where imagine running code where everything you need is provided to you. Every dependency you could want is handed to you. That's what we do. So I can't show you an example of that, but if you come over to my laptop later, I can show you, or you take the red pill, stay at Wonderland, work with us, and I'll show you how deep the rabbit hole goes. All right. I haven't talked about hardware, and that's because we write apps this way, sort of don't care about hardware. Most of our stuff runs under Roku. It's way awesome. When we get backed up on something, I can just spin up 10 more dynos, spin them down. It's wonderful. We do use some EC2 servers because some of our code, that injectable stuff I was talking about, can use a lot of memory and it's unpredictable. So like Heroku will kill you if you get over a certain memory threshold. And just if you have a piece of work that's taking hours to complete and it's using up a lot of resources, it probably is one of the ones taking hours to complete, and then Heroku so we ended up doing that. They don't, the performance is not nearly as good as if we manage our hardware. But we're a small team. I don't want anybody thinking about hardware. I want them thinking about this cool Ruby stuff. So this has worked really well for us. I've never regretted it. I can imagine wanting to move the database to like a hosted professional environment because of continuity and service level agreements and stuff like that. Because once a year, Heroku has a pretty big outage. Amazon has an outage, which takes down Heroku, it takes down like half the companies on the East Coast. So I don't want that to happen. But the point of my talk and why we take this approach to hardware is that we're optimized for flexibility and disposability. We'll throw things away, redeploy things without having to worry too much about too much ceremony. These are some of the main services we use. We try not to build anything. We want to use whatever's out there. It's awesome. We try to use it. Of course, there's plenty of downsides. Well, there's some downsides to doing things this way. It's definitely harder to understand that. I mean, like one feature could involve 5 of those apps that I showed you. Beautiful, each app only has to worry about one little part of it. Their little piece gets done. But if you're trying to comprehend the whole thing, they're very difficult. If you're working in Rails engines, you have like 20 engines, 15 engines, and you're trying to update assets in one to get the asset pipeline to work, that's a whole rigmarole. These guys are awesome and have made really good tools to hide the rigmarole. But we had to go through all that stuff before we started to benefit. So I'm not definitely know what you're getting into when you do this. To me, this was worthwhile because I knew we were doing something super complicated and intense, and I just wanted to embrace the complexity up front and pay a technical cost so that later we didn't have some kind of spaghetti mess thing that took like 30 minutes to run. Horrible. And I think I have a suspicion that type issues become more of a problem because we have a lot of code that's taking things, serializing things in and out of Postgres and Redis, passing stuff around, sending JSON messages back to the user. So I'm uncomfortable with the amount of code we have that's hey, if this thing's an X, you should do that. If it's Y, you should do this other thing. But so far it's working so well. We're growing and succeeding. So, but I'm keeping an eye on that. It's the thing I can see us pushing towards a more type enforced language because of that down the road. All right, so that was a lot to cover. I feel like I finally got this out of my system and said what I wanted to say on this subject. Does anybody have any questions?
So, do you have a module or an app or a gem that just handles active record models so you can access these things that you share?
That's totally
or
good
do
question.
you simply just do Postgres queries?
I totally forgot to talk about that. Yes, we do use active record models. We have a gem that just has, I'll just show you real quick. This is it's just concerns. I'll try to show one that is not too crazy. They're all kind of crazy. I'll do this platform. So any of our apps that wants to interact with the platforms table, instead of them having to make their own model called platform, which we used to do, you can just include this deeply nested thing here and you get all this stuff. So your platform will know about categories, it will know about all these relationships and delegations. I mean, this is like the oldest class we have. I'm kind of, it's doing way too much at this point, so I'm not, just so everybody knows, I don't think I'm the greatest programmer in the world. This is a lot, but we'll get to it eventually. But at least we don't have this duplicated all over the place. And it's pretty common that if you want to add something in particular, like, I don't want to search for, every app has a little bit of a different thing that it does with the platform. So you're always free to include the module and then override behaviors. But one of the reasons why the test suites always run so fast is that all the integration tests for this stuff is inside of one gem. So this one takes 2 minutes to run. So those, I mean, I don't think it was those Brian's being, you and I kind of worked that out. We finally realized, like, why are we duplicating all this active record stuff? We should be using our own advice and gemify the active records.
What's the performance difference if you do it the old way versus this way?
So the question was, what was the performance difference?
When somebody goes to the website to run something.
To be honest, like the volumes of data that our users deal with, we're not trying to make it fast, but not performance sensitive. As long as we answer a request in less than 30 seconds, it's not too bad. So I think this would do well with performance stuff because all that would be concentrated right at the end. I have no fear of introducing caching into this. I think it will be super easy because of that shell that I talked about. Like the caching would go right at the hour boundary of the shell. I think it would go pretty well. But maybe I'll have to come back and do distributed application performance.
So in terms of like the cognitive load with your team working through all the different apps, does it tend to be like, certain people will kind of gravitate to working on certain parts of your system, whereas other people work on other parts? And like, especially like with your gems, like if you need to make changes in them, like how does that work within the team? Like,
that's a good question. Well, there's only 7 of us now, so it's not too. I mean, I don't think there's any one person that understands how all this stuff works. So like, I don't know that much about how I specialize a lot in getting the stuff into Redshift or warehouse, and like most of those guys, Brian, his team, they really focus on getting stuff out of the database, like designing the reports, and making the reports look good, and all that, making them interactive. So yes, we do naturally gravitate. I try, if I see a case that looks like pretty self-contained in our pivotal tracker, I'm like, wow, this is its own little thing. You don't have to know the entire world to get this. I try to pass it around so that everybody gets a chance to see the whole app, at least for generally. But if you need to change one of those gems, it can be that model that concerns gem I showed. That's pretty nasty. So that's definitely the sweep under the rug, because if you have to change that, you might end up having to change it in all 8 apps.
right, because I'm thinking like that's actually something that I'm being presented with right now. Is like I'm deciding on whether or not to move some of our code into private gems, and that was one of my concerns. Is like, if I do that, will it be tougher later on down the line when someone has to go into another repo and make changes there to affect like another part of the system?
I mean, I can definitely show you the procedure we do. Here's our gem file. I was worried about that. It ends up not being that bad. I mean, this is how we do it. We go by the GitHub ref. I mean, that's a lot. But we try to use things like feature flags and have parallel code paths. It's like there's things you can do to make it so that you don't. It's not that often. I don't know, you guys can correct me if I'm wrong. It's not that often that we have to do it, because everything that I'm telling you about, we breathe it in every little line of code in the module, so it's not that bad. And to me, the trade-off is totally worth it, because the individual components are so easy to work on. They run so fast. And one of the things I really like when working on one of these engines is I don't have to think about SSL, cookies, forgery protection. In fact, I don't have to worry about styling really, because we have another engine that provides the styling. So it's like a form. I just want to make sure this one little thing works. It's wonderful.
So I see you're doing it's a points to GitHub.
Yeah.
How does that work with Heroku? Do you vendor it?
Yeah, you have to. If you do that, you have to have a bunch of stuff in vendor cache.
Yeah, because this is what I'm doing something, but it's just one. We have to vendor it, and that's really annoying. So
yeah, no, there should be a way to privately connect. Yeah. What you don't have, but I actually think it's probably a better idea to keep local copies checked in the source control anyway, because if GitHub goes down, you can still deploy that. Or if somebody you know, if somebody yanks the Domino 0.5 gem, it's fine for us because we keep a copy of it. But so this is all trade-offs. I wish somebody explained that to me when I was getting started. Like, you know, there's definitely gonna be things you sweep under the rug. But those are two good things I didn't think about. But like I said, it's something I feel it's better to embrace that stuff up front. Just like, let's just design for it and, you know, suck it up when bad things happen. All right, thank you very much, guys. Really enjoyed it.
All right, next up is going to be Eric Ostrich talking about OAuth2. While we get started on just a reminder, next month we've got a talk on React, since that's the big thing that's going on that people are really interested on. Kyle is going to be talking about React on Rails, so if they want to come to us. And we're also doing the object value serialization next month. We have space for some smaller talks, some talks on more lightning talk kind of things. Those are a really good opportunity for people to get, you know, first-time presenters to come here and just identify something that's, you know, maybe a little bit more like, you know, beginner level or, you know, intro level kind of stuff. So if you're interested at all in presenting here, you know, just find something that's out there and present it. Love to have it. One of the really nice resources for the Ruby community is Object Rim's Ruby Tapas. And he does, you know, those are 5-minute videos that he does, you know, a couple times a week. Really highly useful, great resource that's out there. I think that, you know, we can do that kind of thing here as well. If you're interested in doing that, just let me know. We'd love to start doing that next month. But I think we're all set. Eric, talking about OAuth2.
All right, so this is OAuth2. Eric Ostrich, I work at SmartLogic. These are the obligatory links. So what is OAuth? So everyone's used it at some point in their web career. So you go to a page that says sign in with Twitter. You click the link, it goes off to Twitter. You sign into Twitter, and then it says, do you want to, are you sure you want to authorize? And then at the very bottom it says, your password is not sent. So you click authorize, and then you get redirected back to the site you're at with credentials. They know who you are on Twitter, etc. So that's what OAuth is. So here's the OAuth2 RFC. I figured we could just read from this. We'll just start at page 1. So actually, if you are interested in this, this is a lot easier than I expected. I'll be pulling a few things from it as we go. So that's the RFC. That's the entire spec of what OAuth is, specifically the second version, I should say. So here's what I just subscribed. This is straight out of the document, so you'll notice that it's all courier new. Right, so we have the client sends an authorization request to the resource owner, which is you as a person. And it's you as a person on the server or on Twitter. So you'll say approve. You'll get the authorization grant. It comes back to the client, so that your server, and you get an authorization code with the grant. Right, so you take the code, and then you go to the authorization server and you turn it into an access token. And with the access token, you can request protected resources. So we get all your tweets or all your Facebook posts or whatever. So from the client side, you use OmniAuth, and you just send requests with access token equals, and you're pretty much good. So that's the boring part. Let's talk about the server side. So this was what I mainly read the OAuth2 spec for, to see how it worked, look under the covers, see what's happening. So this is specifically, I'm just going to show you the authorization code grant type. There's four types. There's the authorization code. There's a client one for mobile apps. There's one that's you are writing your own app against your own OAuth server. So like Twitter's apps use that one. That one you actually do pass around passwords. So it's like there's a specific in the section, it's like, you really don't want to do this unless you trust everything in the system. And then there's one more, I forget what it is, and I think that one's specifically for native apps. Before we continue, I just want to mention that SSL is ridiculously important in OAuth2 because that's pretty much the entire security model is just SSL, that's it. It's crazy how little security is like baked into it. I was very surprised when I found that. It's just kind of trusting on SSL and then domain name storage, which is, yeah.
Can you run it without SSL?
You can, it's just, the spec says you must, but I mean, nothing's stopping you from doing it. That's actually what this is here. So this is all local, there's no HTTPS. So the only thing stopping you is the server that's implementing OAuth that says like, when you create the client application with a redirect, I guess I'll get into this in a bit, you give it a redirect so that when the server knows where to go back, and you can validate that as being SSL only. And you might have, I think if you set up Facebook or Twitter, unless it's like localhost, then they like say, no, you need to be SSL, because otherwise you break everything. Right, so here's the server side. We'll go over 3 things. So there's scopes, authorizations, and then how to generate the token. So scopes are if you've dealt with the Twitter API or the Facebook API, you've seen the scopes. So you can say, or even just signing in through Facebook, it says we can get your friends, your information, but we cannot get your posts. And so that's the app saying, I want the friend scope, I want the you post, or the you scope, but I don't need your message scope. So when you do a request with the access token to any of the ones that you've said, yes, this is what I want, it lets you through. And as soon as you try and get the post, it goes dead, forbidden. No, you can't do that. You didn't request that. So the authorizations, let's go through this is actually fairly simple. So here's the authorization request, right? So we see the response type must be code, the client ID. So it's just any kind of identifier that says this is we have example.com. I am example.com authenticating against Twitter. Here's my UUID so you know who I am. The redirect URI, you can pass in a separate redirect URI or one you've already provided, and the server will just go back to that. It's suggested to validate the 2 if you pass another one in. The scopes that you're requesting, and then this state. So this state is just a way to verify that you're actually going to the correct server, when you go off to Twitter and come back, Twitter should pass that state with you so that no one gets in the middle. And then it just shows what it looks like. I think I have, so here's the response. This is what it has to look like to be OAuth2. So it's a lot less intimidating than I expected, at least for me when I read through this. It's just very plain, like this is what it is, do this. So you post off and then you get the response with the code that you'll then use to generate a token. So that's actually right below it in 413, right? So we redirected off to the server, we got back a code, and then we take a code and we post to /token with the grant type of authorization, the code that you just got sent, and your redirect URL so you can verify again. And then you get back an access token. And so that's pretty much everything. From then on, you have an access token, and you just append it to your request or add it into the authorization header, and everything just works. So here I implemented the spec, and so I guess show that. So here's you're on example.com. You click here, it goes to Twitter. Actually, right. So it goes off to Twitter. It comes here. It says scopes are requested. Self
so I can get your email. So you're sure you want to do this, and you authorize, it goes back, you're signed in. And one of the things that is suggested is to do this. So if you detect that the client has already, or the user has already authorized the same scopes, the same redirect URI, it's the same client, just let it pass through. So that's what this is. So I thought that was cool that we can also show the full, right? So you sign in, you get authentic, you need to authenticate against Twitter. Oops. Right, and then you're signed in because you've already authenticated. And one of the coolest things, I already showed it, but so you can see here, if you've ever gone into Facebook or Twitter and seen like what apps you're connected to, you can revoke it, and then they can't access it anymore. So I just revoked that, and so then this fetches this email every single time. Whenever it gets a 403 forbidden, it just signs you out. Right, so then I thought that was cool. Make that a little bigger. And so it's pretty simple. So this is the authorization. So it finds. So here's the finding the current one. This wanted to show something cooler. Yeah, I mean it's very simple. It's all little teeny methods, and it's like it was just very surprising to see how not much is there to be OAuth2. I kind of just wanted to show that to everyone. This is all open source. It's on GitHub if you want to poke around. Yeah. I don't know, I just thought it was cool to like read this back and implement it.
Yeah, it looks like a client is already like.
Yeah. Yeah, I guess so. And so I guess, so here's how you can, right, so we find the access token, and then you can require require the scope. So each access token, maybe this is useful. So each access token has an array, the scopes. The authorization has the scopes that are requested. So it's just an array text or an array of strings in Postgres, and then so it can just match against it to see if you've requested that. And this is the whole database. Use UUIDs everywhere, so it's all unique and whatnot. That's pretty much it. Any questions?
Are there any questions?
Do you use the Rails session for keeping like that state? Sorry.
Yeah. So there's a set. Yeah, I'm just looking at it. Yeah. So the only thing it saves is the user ID in the session, and that's just on the on like the HTML view. But anytime you use the API with the and access token equals, it should all be stateless because it's just like a JSON API at that point.
All right. Thanks to both of our speakers tonight. Really appreciate that. Again, if you're interested in doing even a short presentation next month, we'd love to have you. If you want a longer presentation, you'll have to wait until April, I guess. So it's really great having presentations. People just come to me with presentations, so I don't have to go out and find them or have to talk to you about Dart. Because I will do that, and I've done that before. So yeah, I think there's probably still a little bit of pizza if people want to do that. And Ed, you're gonna lead the charge to
Hudson Street Stack.
Hudson Street Stackhouse in about 10, 15 minutes. All right, thanks.